Okay, everyone. We got a pump which is actually moving the oil from point A to point B. The pressure at point A is 28 kilopascal, and the pressure at point B is 296 kilopascal. Now, the diameter of the pipe here is 75 millimeter. The diameter of this pipe after the pump is 25 millimeter, and it is lifting the oil of a specific gravity of 0.86 to a height of 1 meter. We need to find out the energy delivered. So what is the energy delivered by pump to oil per unit weight of the oil flowing through the system? We are also being given the flow rate. The flow rate here and the flow rate here is same, which is 7.8 meters cubed per second. So we need to find out the energy delivered. Okay, to do that one, the first thing we need to do is we need to write down the Bernoulli's equation. Okay, now we have to use the Bernoulli's equation to find the losses. So this is the Bernoulli's equation. Energy at point A, which is that energy, should be same as energy at point B. There is no energy created, no loss. So ZA plus pressure at A over the gamma plus velocity of the fluid at A over 2G plus the H added, the head added, minus the head removed, minus the head losses should be equal to the ZB plus the pressure at B over gamma plus the velocity of the fluid at B over the 2G. I can rearrange this equation and I can make this thing a subject. So I need to move, first I move the ZA on this side. So that becomes a ZB minus ZA. Now then I move this thing on that side. This was already there, PB over gamma minus the P pressure A over gamma. Now then I move this thing on this side. So that becomes the VA over 2G. Now there are no losses that are being removed. So I can actually use that one as 0. And I can move the head losses on the other side and I can just add them. So I got this equation. Now we need to find out the specific gravity. Yeah, we need to find out the specific gravity of the oil. Sorry, specific gravity of the oil is given 0.89. Yeah, we need to find out the gamma first. So if I want to find out the gamma, here, let's do the gamma on this side. Yeah, thank you. So if I do the gamma on this side, it's 0.9. No, not 9. 86, thank you. 0.86 multiplied by, yeah, we got the answer. 842.8. Okay, so we got that value. So we are going to use that value to put in these ones to get the answer. Now we have the value for the PB, which is 296. We got the PA, which is 28 kilopascal. Now, so what I can do is I can actually find this bit. I can find this bit. Yeah. So let's find this bit. When I calculate that bit, that becomes how much? PB, which is 296 kilo minus 28 kilo. So 3 zeros divided by the gamma, which is 8428. Yeah, and that will give you the answer. Anyone got an answer? That will be in meters. You can also divide that one by just one go. That will be easy. Yep. 31 points. Okay.
I just got 31.8. 31.8 I got.
31.8.
Yeah.
31.8. Okay, we got 31.8. Pressure. Oh, okay. I made one tiny mistake here. The pressure.
I got 31.8.
Yes, I made one tiny mistake here, guys. The pressure I'm using is 28 kilopascal here, and the pressure I'm using that one is 296. Because it is working against the gravity, the flow is against the gravity. This pressure, when I'm doing it, that should be a negative pressure, which means when I bring that one here, that should become a positive. Now, if you try that one, guys. If you try this one, you will get an answer.
38.44.
38.44. So we got the pressure at 38.44 meters. Yeah, not the pressure. The head losses because of this thing is 38.44. Okay. Now we got the value for ZB minus ZA. This is 1 meter. So I got that one. Now I need to find out the values for this bit. So I need to find out the values for this bit. Now I got the flow rate and I got the area. I can just find the velocity. So I'm going to use the continuity equation. Q equals to V times A, where V is the velocity and A is the area. So if I want to find out the V, V equals to Q over the A. Now the Q is 7.8. Now the area, I'm finding the velocity at point A, which is that one. The area, I'm going to use that area, pi r squared. So pi, and r is 75/2, with half of that one, times 10 to the minus 3. When you do that one, you make sure you actually put the square afterward. Try to use the fraction button in the calculator. And that will give you the velocity at point A. And if we got the velocity at point A, we can also find out the velocity at point B. So that will give you the VA. To find the velocity at point B, it's going to be Q over the area of the B. The Q is the same, 7.8. The area is going to be pi r. The radius is going to be half of that one, 25/2 times 10 to the minus 3 and square. So we will get the VA and we will get the VB.
Like 7.5.
It's going to be meters per second. That is minus 3, yeah? Make sure that's minus 3.
What do you think of it? You got 78, 7.8. Oh, come on.
Come on. Happy?
It's me and the math class of you. 117.
What, 50,000?
Okay, now we got the velocity at A and we got the velocity at B. We use the continuity equation. Now, what we need to do is, the reason the velocity is so high to that type is because the flow rate is 7.8 meters cubed per second. 7.8 meters cubed per second is of, what is that one? This is oil. So it's much lighter than that one. it's around 7,800 liters of water per second. So hence velocity has to be massive. The pipe is yeah, exactly. Okay, now what you need to do is we need to find out this bit. We got that bit, so we need to find out this bit. To find that bit, what we're going to do is we are just going to put it in that equation. So VB square over 2D minus VA square over 2D. To make your life simple, you can do like that. You can just put the 2D as in one go because it's still going to give you the same answer. So VB is 15,890.2. And if you square that one, minus VA, which is 1765.56, and square that one, divided by 2 times 9.8. And that will give you. Now, when you do that one, the answer you get is 12.7 times 10 to the 6. Now, we just put that answer straight here. Now, after that one, let me just. Okay, now the head losses is given in the question 1.86 meter Newton per Newton. So what we're going to do is we are just going to put these ones. And obviously the answer is going to be the big massive number because you got big massive number then added by a small different number. So the head added is going to be around times 10 to the 6, around that number, you know. But that's the answer. I will upload this video online.